Hi everyone, today we're going to talk about finding the area of composite figures. Alright, so finding the area. Our first step is to take that composite figure and divide it into known shapes and then label any missing sides that we need to find the area. Step 2, calculate the area of each plane figure. And step 3, we're going to add or subtract the areas depending on what the equation is asking you to find. Alright, so let's take a look at this first one here. We want to find the area of this particular shape. So what we're going to do is we're going to split up into two different shapes. I kind of see the slanted side, so I can envision a triangle being there. So I'm going to draw a line in so that I can now have a triangle. Now I have a triangle and a rectangle. So now in order to find our area of this triangle, we need some information. We need to know what this base is, and we need to know what the height is. Well, the height is going to be pretty easy because it should match this side here. So I know that this will be 3, but now I have to figure this part out. Well, if I know the entire length of the bottom of this shape is 14, and I know that the entire length of the top is only 10, that tells me that from here to here is also 10. So to make up that 14, to get from here to here, I need another 4. Alright, so now I can go ahead and find the different areas. I'm going to start with this rectangle. So be careful when you do the rectangle, okay? The formula is length times width, but we need to make sure we're using the right numbers. So the rectangle is this 10 by 3. Remember that 14 is the entire bottom beyond the rectangle, so we only want the lengths that match up with the rectangle itself. So 10 times 3 will give us 30. Alright, now the area of the triangle. Remember, is our 1/2 base times height. Base is 4, height is 3. Do the math, and we end up with an area of 6. Alright, so now to find that total area, we're going to take those two values, that 30 and that 6. We're going to add them together and we get 36. So my total area is 36 feet squared. Make sure that you always label your answers with the unit of measure, and when we're doing area, that unit of measure should always be squared. Alright, I'm going to skip over the try on your owns for now, and then after the end you can come back and work on those. Alright, example 2. Find the area of the following shape. So the picture did not actually give you guys enough information, so I want you to add in this piece here, this line with the 5.2. We're going to need that. Alright, so in order to do this, we now have two different shapes. We have this trapezoid, and then we have this half of a circle. So let's go ahead and find those two different areas. I'm going to start with the trapezoid. Remember, the trapezoid has an area of 1/2 the height times base 1 plus base 2. So my height, and then my base 1, and my base 2. I'm going to substitute those numbers in. I'm going to do some math, simplify. The 4 and 10 is 14. And now I can multiply everything together. Right, now let's take a look at this guy here, the half circle. Well, I need to know the diameter. Well, if I were to take this guy out, we should be able to see that this side and this side are actually the same. So it has a length of 6, or a diameter of 6. Now here though, the area formula uses radius. So remember, radius is half of the diameter, so my radius is actually going to be 3. Substitute my values in, evaluate the exponent, and then I can finally multiply those together. Alright, now remember though, this is half of a circle. So we actually need to take this, divide it by 2. So the actual area of that half circle is 14.13. So now we can take these two values, we're going to add those together, and we end up with 50.53. Since they did not provide any units of measure here, we do not have to label our answer with any unit of measure. All right, now let's take a look at what happens when we have shaded and unshaded sections in a picture. Here they want us to calculate the area of just the shaded region. Okay? So one of the things that I always like to think about with this is, let's say I've got a piece of paper. I can find the area of that paper, but then what happens if I cut 2 holes in the area? Well, now I've got less paper. I've got less area. I have to subtract out the area of those 2 circles I just cut out. That's exactly what we're going to do here. So we're going to start with our first step, okay, where we're going to find just the area of the entire rectangle. Okay. So the original rectangle, we're going to find its area. So I'm going to do 21 times 10.5, and we end up with 220.5. All right, the next thing I'm going to do is find the area of those circles. Remember, that's pi r squared. All right, well, that means that we need a radius of these circles. Well, if the height of my rectangle is 10.5, we can see that these circles go from top to bottom of that rectangle. So we can say that its diameter is also 10.5. Whether I look at diameter as a vertical line or a horizontal line, it's not going to matter. They're going to be the same. But I don't want the diameter, I want the radius. So my radius is that halfway point. So it's going to be 5.2. Or 5.25. So this is the number we're going to use over here in our formula. I'm going to evaluate my exponent and then multiply those two together. Now, we actually have 2 circles here. So this time, this is the area of 1 circle. I want the area of 2. So I need to multiply by 2. And we get a total area for our circles as 173.08. All right, our last step. Remember, we took a piece of paper and I cut out 2 holes. So we found the area of what that piece of paper was to start. We found the area of those 2 holes. We want to figure out how much is left over. So I'm going to take the original area, subtract out the area of the 2 holes, and we are down to 47.42 centimeters squared. Okay. This problem, next problem, will be a try on your own. And let's go to the next page. We're going to do one more similar problem. So this time we're at a playground, and Ben wants to fertilize the grass at the local park. The area of the grass-covered portion is shaded in the diagram below. What is the area of the grass-covered portion of the park? So we're not going to worry about the area for the swings or the slides. Now, why is this important? Well, when you want to go to the store and buy fertilizer, you need to make sure that you know how much area you have to cover. So you need to make so that you know if you're buying enough. You want to make sure you buy enough or that you don't buy too much. You don't want it to make multiple trips back and forth to the store or spend more money than you really need to. So you figure out your area first of everywhere you want to seed, or in this case fertilize, and then you can go out and buy what you need. All right, so first, let's find the whole area of that rectangle. The whole area is going to be length times width. So that's going to be my 70 times 100, because it's 7,000. All right, now let's find just the area of the swings. All right, the length times width is going to be 20 times 60. Gives me 1,200. And now let's find the area of just the slides. So length times width, 20 times 20. And that gives me 400. Alright, so now I know all those individual areas. Well, remember, it's really kind of shaded area versus the non-shaded area. So let's take those 2 shaded areas, my swing and my slide, and combine just those 2 together. So that's the 1200 plus 400 is going to give me a total of 1600. So I have 1600 square feet that I do not want to fertilize. So since I do not want to fertilize that, I can take my original shaded area, subtract out the non-shaded area. Okay, 7,000 minus 1,600 will give me 5,400. So the area of just the shaded area is 5,400 square feet. All right, you got one more try on your own, but I do want to just kind of show you something on this one. This one's a little tricky. So Susan wants to put new carpet around her roller skating rink. This darker shaded area is the roller rink. The striped part all the way around is the carpet. The image below shows her rink with her new striped carpet around the rink. What is the measurement of the area that she will need to place the carpet? Okay, so we only want to carpet this outer edge. So think about before with the shaded and non-shaded area. First, you want to try and find the area of this entire oval, everything inside. What's the total area? So find that area of that red oval. You've got enough information to know, to be able to break this up into a rectangle and two half circles, to know your total diameter from edge to edge, right? And to know your total height and length, or width and length for the rectangle. The next thing you need to do then is find the area of just the inner oval, just that inside oval. Once you've done that, you're going to subtract them. So now I want you to go ahead and make sure you do the rest of that. So this is the end of our notes. I want you to make sure you've completed all your try and your owns before next class, and I will see you then.